Okay, well today for this lecture we're going to be talking about looping in Python. So looping is an interesting concept because it can help you solve some pretty complex problems. And if you remember from last time we talked, we were trying to, one of our activities was to create this age input program. And one of the challenges I gave you was come up with a way to input people's age, find out what grade they're in, and then based on their selection, give them a different math problem. And so as you're looking through this code, I was able to accomplish this with this whole series of if and else if and else statement at the end. So I was able to accomplish that, but it took a whole long daisy chain of else and else if statements. Now, you can do it this way. It's just the problem is the code gets complex. In addition to that, the code has a lot of room for error. And also there's a lot of room for if I need to make a change later, I have to change a whole bunch of lines of code up and down throughout the entire code base. So else and else if statements are good and they're used for logic, but we typically try not to use them to solve or reiterate through many options. And so today we're going to talk about looping because looping gives us the ability to do that. The primary thing that looping helps us with is accomplishing repetitive tasks. And, and that's the whole purpose is to loop through something and do a whole bunch of repetitive tasks. And so we're going to talk about that. Now, there's two types of loops that you need to deal with right now. The first loop is a for loop, and the second loop is a while loop. Now, for loops are defined for a particular collection of objects and are executed so many times. So, for example, the code will loop through a code block for so many objects until it's finished with those number of objects, and then it will stop. So for is always a defined length of time based on a number we provide or a range of numbers or whatever. A while loop will continue to execute forever until an expression becomes true. So while will keep going until an expression happens. Now, for and while loops can oftentimes solve the same problems. So we may have a reason to do a loop, and we could either do it with a for loop or a while loop. Now, the reason why you would decide one or the other is because you want to reduce the processing time or increase the speed, or it's just easier to do with one or the other. Before we begin, though, we need to introduce a new command. So I'm going to introduce this thing called the range command, and I'm going to go ahead and create a new file. And I'm going to save this file as, and we'll call it, I'm going to call it factoring.py. So this file is called factoring.py. And so I'm going to go ahead and just demonstrate a little bit of how to use this command called a range command. So I could say x. I'm going to create a variable called x. I'm going to make x equal to a range of numbers. And we're going to say that range of numbers will be 1, 10. 1 being the first of that range, 10 being the last of that range. And then, just to see what happens, I'm going to go ahead and print x. And so let me save this now, file save. And over here, I'm going to go ahead and execute my factoring.py file. Let's see what happens. Oh, all right. It kind of worked. It printed the range 1 to 10. That was interesting. It's not exactly what I was expecting to have happen, actually. That's weird. So I printed the x. X is equal to the range 1, 10. Oh, that's about the way it should look. All right, I realized what I was doing. There's a subtle difference between Python 2 and Python 3.5 that has hit me here. So effectively, instead of displaying the entire range 1, 2, 3, 4, 5 all the way to 10, which is what it used to do in Python 2, what I have to do now is you either have to use the list command specifically to list it out, or you have to use the for loop to cause this to happen. So this is just going to introduce the concept of using a for loop. So we'll go ahead and do that now. So I'll just say for x, so for x, and x is going to be defined as a variable. You can define a variable inside the for command, so that is okay. So I'm going to say for x, I'm going to say in instead of equals. I will say in this range from 1 to 10, right? I'm going to go ahead and then I'm going to indent this because it's part of the for command. I'm going to go ahead and print x. So I'll save that now, and we'll see if I get the result that I was looking for before. And no, I don't get the result I was looking for before. That is because I'm stupid and didn't put a semicolon. Yes. All right, so I will save that again, and I will run the command again. So there we go. Now I get what I'm looking for. 1, 2, 3, 4, 5, 6, 7, 8, 9. What is actually happening, the range 1, 10 is actually an entire list of values from 1 to 10 that are sort of in an array of values or a list of values. And so what's happened now is the for loop has gone through each one of those values and printed them each time until we ran out of values. And so that's effectively what happened. Now you'll also realize that the number 10 at the end did not get displayed. So you should remember that the range command, the first number is included, the last number is not included. So that's just something to remember when you go through the for loop command. All right, so hopefully you understand that the range command. Now I think I can show you what the range actually looks like. Let me show you what that. If I were to use the list command, so let me try list range, and I'll range numbers of I'll range all the way up to 10, right? So I'm going to list the range to 10. And I'll save that now, and let me see if I produce the other result so you just can see. No, it doesn't do that for me. That actually produces the range in a list. Let me see if x equals to, and now print x. There we go. That's what we're looking for. So notice that I've set x equal to this list, and the list is the list of everything in the range from 10 digits. And then print x is giving me then that printed list. And so you're seeing this a list of numbers, right? Rather than what we were doing before, which is iterating through each number and then doing a print statement. Just to give you an idea of here of how this list command works, if I put a 2, 10, I'm only going to see 2 through 10, 2 through 9 in that number because it doesn't print the last one. Save that one, run factoring, and now notice it's 2 through 9, if that makes sense to you. So that was pretty interesting. You now understand what the range command does. You also understand a little bit about the list command, and more importantly, you understand that we can use a for loop to go through each one of those things in that range. Now, we can get a little crazy with this, and in fact, why don't we? So I'll say for, we'll just keep up, we'll go for a number. So I'll say for a number. So for a number in range, right? In range 1, 1000. So let's go all the way to 1,000 numbers. Put my semicolon, and then what I'm going to say is print, and then we'll print a underscore number. All right, so I'm going to, for this variable I'm calling a underscore number, I want to print all the values from 1 to 1,000. So let's see what happens when I do that. You should guess what those results are going to be, but you'll see. I get all my list of numbers 1 through 1,000. You see that? I get this entire list of 1,000 numbers, all printed one after another. And that's basically how this range works. Now, what I wanted to show you this, though, is that I have another command with the range, which is I can skip every so many numbers. So let's say I want to skip every 100 numbers, or let's go with every 10 numbers. I want to skip every 10 numbers. So I'm going to go ahead and save that. And let me clear my screen and run my file again. And now notice that in this case, it skipped every numbers from 1 to 1, 11, 21, 31. So it skipped every 10 numbers, right? Pretty interesting. So let's go ahead and try that again. In fact, this time I'll do every 100 numbers. So I'll skip every 100 numbers. I'm going to save that. And there we go. I'm going to run the file. And now I've skipped every 100 numbers. And you can see that the range command allows me to skip to numbers just like that, right? All right, pretty interesting. So you can play around with that. You can also do an array of strings. And let me demonstrate how to do that. So I'm going to set this variable called letters, and I'm going to make letters equal to a whole list here. And you create the list with brackets. So I'm going to do brackets, and I'm going to put in quotes the letter A, comma, and then I'm going to do in quotes the letter B, comma, in quotes the letter C, comma, and then in quotes the letter D, comma, and then finally in quotes the letter F. Oops, in quotes the letter F. So here I've got a list or an array of A, B, C, D, F. And that's what letters is now. So letters contains that list, all separated by commas. And then I'm going to say to get my grade, so for a grade, I'll have this new variable called grade. For a grade in letters, right, I'm going to hit exclamation point. I'm going to put my colon, and then I'm going to say print, and here's what I'm going to say, grade, comma, and then quote, is a possible letter grade, right? So let's walk through what we think this is going to do. I've got a group of letters here in a list format, A through F, and I'm saying that for grade in letters, print grade, and I'm going to print each one of these, and I'm going to go through this entire list one by one, right? I'm going to print each of these one by one by one, and we'll see what happens. So I'm going to save this, file save, and let me run my factoring program. There, A is a possible letter grade, B is a possible letter grade, C is a possible letter grade. So it's iterating through and repeating each one. So this is a pretty cool way of doing a count. Now, you can imagine you can put anything you want to do in here, right? I could put, let's just play around. I'll do friends, right? And my first friend is Bill. My next friend is Mary. My next friend is Bob. My next friend is Alice. And my final friend is White Rabbit. Uh-oh. White Rabbit is special. Oh, that's because I didn't put a quote around Alice. I thought I was running some freaky Python thing there, all right? So I'll say, for messages in friends. So I'm going to send a messages print, right? I'm going to print, let's see. Messages is a possible, oh no. Okay, so we'll print messages. Let me see, what do we want to say? Hello. Boy, now I gotta put this in quotes. Hello, space, comma, messages, right? Hello, messages. And then I'll put in quotes. You are a good friend, right? I think I got it right. Let's see if I messed up. So I'll go File, Save. I'll go over here, and let's see what happens. Oh, I messed up somewhere. Where did I mess up? Messages. Oh, I got to spell messages right. Syntax is important. No matter how Python hasn't figured out how to fix your spelling errors yet. All right, so there we go. Oh, hello, Bill. You're a good friend. Hello, Mary. You're a good friend. Hello, Bob. You're a good friend. Hello, Alice. You're a good friend. Hello, White Rabbit. You're a good friend. Now, what we could do is we could find out. We could figure out a way, and I imagine you can think of how to do this. That when you get to one of these, you say, no, nah, you're not a good friend. So for some people, you're going to say a good friend, but for other people, you're going to say something else. So you could do that with a for, else, and an if. You could do all that right here embedded inside this command. So you can see there's a lot of power here. We can do lots of fun stuff. All right, now let's go ahead and move on because we're going to get to something more interesting. So what we're now going to do is we're all together here going to solve a problem that bugged me when I was a little kid. So I'm in math class when I was in 8th grade or 6th grade. I forget, 6th grade probably. So I'm in 6th grade and I always had to do factoring, right? So they would give you a number and I had to figure out what the factors were for that number. So it really bothered me that they give me a number like 98. And I'd be like, well, just a simple example, the number 50. So I sit there and figure out, okay, what number goes into 50? I'd be like, oh, 2 goes into 50. And then that would give me 2 times 25. Then I'm thinking, well, what number goes into 25? And I sit there and have to try to figure it. Does 2 go into 25? No. Does 3? Does 4? Does 5? 5 goes into 25, right? And so I keep going down this path, and it really bothered me. And I hated doing that. So could we figure out a way to do that in Python and solve my problem I had when I was a little kid? So let's go ahead and see if we can figure that out. So I'm going to get input. I'm going to get a whole number input from the 6-year-old guy. So I'm going to say, I'll call it whole input. So I'm going to get a whole number, and I'm going to say input. So I'm going to get some input from the user. I'm going to say, okay, what whole number would you like to know the factors for, right? So what numbers would you like to know the factors for? I'll put a question mark at the end there, all right? And so then I'm going to get a whole number input. Now, I want to make sure that this whole number that gets inputted gets converted to an integer. So I'm going to say whole number equals an integer of whole underscore input. So do you see what I'm doing? I'm getting the number I'm calling whole input, which is the whole number that I want somebody to give me. And then I'm saying that I want this thing called whole number to be equal to an integer of whatever they gave me. So now I've got an integer in the value whole number. Hopefully you're following with me. We've been down this road before. So now we're going to go ahead and we're going to use the for loop. So let's use a for loop. And what I'm going to do is I'm going to go through, well, we're going to figure this out because I got to figure out a way to determine if something has a factor. Now I know if I take a number and I divide it by another number, if it produces a remainder, it is not a factor. So if I took 7, and divided it by 2, right? So 7 divided by 2 does not produce, will produce a remainder. So if there's a remainder, that means that's a problem. So if I were to open up our idle program here, I'm going to open up idle. Let me show you. So I'm going to take 7 divided by 2, and I'm going to get it at 3.5, right? Well, there is a command where I can take the modulus of 7 modulus 2. And what that does is it tells me how many remainders are from 7 divided by 2. In this case, it's telling me there's one digit remainder, right? So I know that there's a remainder when I do 7 modulus 2. So if I take 2 numbers and I do a modulus of them and I produce a remainder that's not 0, that means I've got a problem. So for example, if I do 9 modulus 3, I'm going to get 0. So therefore, I know that 3 is a factor of 0. 3 is an absolute factor of 0 because I get a modulus back of 0. Makes sense? So 100 modulus 10, pretty simple. I am going to get a 0 back. There is no remainder when I do that, right? However, if I do 97 modulus 3, I'm going to get a remainder back, right? So you now know how to use the modulus command. So I'm going to use the modulus operator, this little percent sign. I'm going to use the modulator percent sign to figure out whether or not a particular thing is a factor. But what I want to do is I want to take the whole number that somebody gives me. I want to take any range from the number 2. I don't care about the number 1 because number 1 always is a factor, right? Even prime numbers have number 1 as a factor. So I'm not going to use the number 1, but I want any number from 2 all the way up to the whole number that somebody inputs. I want to see if any of those are factors. So I'm going to say 4, and I'll call it factor range. I'll call it factor range, right? So for the factor range, in the following range, right, from 2, comma, and what's my last number? Well, I want my last number to be the whole number that is inputted by the user. Now, this is a for command, so I have to put a semicolon. And what is expected after the semicolon? Well, a statement is expected. So basically what's going to happen is the following statements will be executed for every number in the range, from 2 to whatever number somebody inputs. So if the 6th grader guy inputs the whole number 100, then 2 to 100 will be in this for loop. Okay. So now I can embed inside the for command if statements, right? So I can now say if. So if the whole number has no modulus, then I want to print something that says, hey, success, right? You found one, right? So let's say if the whole number, right? So I'm saying if the whole number, and I'm saying modulus, if the whole number modulus of the factor range, right? Factor range. So pay attention here. So if the whole number that it was inputted by the 6th grader guy and is modulus to factor range, so one of these numbers from 2 to all the whole number, it's going to go through them one at a time, right? It's going to start at 2, go to 3, go to 4, go to 5, go to 6, go all the way up to whatever whole number that we enter. I'm going to do a comparison on that. Now, if that is equal to, and remember, I don't use the equal to command, I use the double equal sign, which is the actual equal to operator. A single equal to sign is the assignment operator. So the double equal sign means actually equal to. So I'm saying if whole number modulus factor range is equal to 0, right? That means there is no remainder. So if it's set to 0 and there's no remainder, that means yes, I found a factor. However, there is a problem here. It'll be set to 0 in 2 conditions. First condition, I found a factor. It'll be set to 0 if I found a true factor. The second thing that will happen is if it is itself. So a whole number always will have a no modulus to itself, right? So 10 modulus 10 will be 0. So in that case, I need to say and, right? I'm putting some logic in here, and the whole number is not equal to the number, it's itself, basically. So I'm saying that hey, we're gonna say the only way this if will work, the only way this statement will be true, is if the whole number modulus of the factor range is 0, meaning no remainder, and the whole number is not equal to itself, right? And it's going to iterate through. This factor range number is going to go from 2, 3, 4, 5, 6, 7, 8, all the way up to the top, right? Now, this if statement is a command called if, and so I basically provided the expression here. So this is the if expression that will be evaluated on true or false. So therefore, I must put a semicolon, because if it is true, then the next thing is going to happen, right? So let's go ahead and play around with what that would look like. So I could say now print, okay, so I'm going to print a success message. So I'll print, you know what, the factor range, so the number that we're talking about right now, comma, and I'll put in quotes, is a factor of, right? I'll put another comma. Remember, I'm just putting in, using the print commands function of stringing together things. So I'm saying the number we're working on now, so maybe it's 2. 2 is a factor of, and then I'm going to go ahead and put whole number, comma. So I'm saying that that number is a factor of the whole number, right? Good job. And then maybe I'll add some more here. I'll say, because, right, comma, and why? Well, because the factor range, so because the factor range, comma, and I'll put it, is multiplied, because the factor range multiplied, comma, by the whole, number divided by the factor range. So when you take the whole number and divide it by, so if you take the factor range and you multiply it by the whole number divided by the factor range, that should be equal to the whole number, right? So whole number divided by the factor range, and I'll put that, I'll put a comma after that, and then I'll say equals, and we'll say comma, whole number. Well, that sounded fun and complicated. We'll just have to see it in action. So let's go through this really quickly. I probably messed this up. I was kind of writing this ad hoc here. So let's see what happens here. So I'm saying the factor range. So 2 is a factor of 10 because 2 multiplied by 10 divided by 2 is 5. So 2 divided by 5, 2 multiplied by 5 is equal to the whole number, which in this case is 10. So if somebody inputs the number 10, the first factor it's going to look at is the number 2. So let's go back through that again just to make sure you understand it. So I'm saying that 2 is a factor of 10 because 2 multiplied by 10 divided by 2 is 5. So 2 multiplied by 5 is equal to 10, which is the whole number, right? Boy, that was fun. So we wrote this really cool statement out. We're going to let somebody know when there is a factor, right? That's all we need. Now, if it's not true, the way we have it right now, if it's not true, this program is just going to die, just quit, right? So let's go ahead and run this and see what happens. So what whole number would you like to know the factors for? Okay, let's try our 10. 10. 2 is a factor of 10 because 2 times 5.0 equals 10. And 5 is a factor of 10 because 5 times 2.0 is equal to 10. Hey, it worked. This is pretty cool. Now let's clean it up a little bit. One thing I notice that on this number it's giving me an integer, but on this it's giving me a floating point. 5.0 is a floating point. That's because whenever you divide numbers, it automatically gives you a floating point result. So if you look right here on our line number 6 here, you'll see right here at some point here, yeah. See, I've got a division problem. Whenever you have a division problem, it produces a floating point. So I'm going to type integer. I'm going to convert this to a integer. So let me save that, and let's run it again, and we'll do 10 again. Aha! Now I got rid of that 5.0, 2.0. See that? And I've also got a couple of extra spaces in here. I've noticed. I got to go clean up my spaces, right? I've got factor of, and I've got a little extra space in there. I could probably clean that up. And then 10 because that looks like a little extra space. I think I need a space there. Let's see here. And it looks like I've got equals. Oops. Let's see if that cleans up my spaces. Let me save that. And let's go 10 again. Yeah, that looks a little cleaner. All right, so there we go. We found our factors. Let's try a much greater number just to see if it works, right? Is our theory going to hold true? So let me go all the way up to, let me do 100, right? There we go. Let's see. Does that look correct? 2 times 5, 4 times 25, 5 times 20, 10 times 10, 20 times 5, 25 times 4. Yeah, it does look, it looks pretty good. Those are all our factors. Wow, 6-year-old guy is really, really happy. So I could do, let's do my 50 example. There we go, sweet. Let's do 49. Oh, 7, that's the only factor of that one. Now let's do the real kicker. Let's put in a known prime number, 7. We know that's a prime number. Oh, it just errors out. It just quits. So see what happened up here? When I put in a prime number, this if statement is not true. I'm actually getting a on every number from 2 to 7, I got a this if statement was not true. And let's try a larger prime number, 97. I know that number's prime. That's a prime number before you get to 100. So I'm doing 97, and same problem, right? There's a whole string of numbers from 2 to 97, and every one of those numbers did not meet this if test. So therefore, it just goes away. There's no further instruction. So I have to give it further instruction to do something here. So let's talk about it. So I right now I've been able to print some interesting numbers. I can print the factors. So let's talk about what would happen if I said, you know what, right after this, let's talk about this. Right after the else statement, right after the if, let's do an else, right? So else colon, right? And let's print let's say this number, factor range, right? And I'll put in quote, is not a factor of, and let me put quote, whole number. Oops. So I'm saying the number that I'm working with in the factor range is not a factor of the whole number. So wonder what's going to happen. So I'm going to print this. So it'll be interesting to you to see what happens, right? So I'm going to save this, and I'll clear my screen and run that. Let's see what happens. So let's do 49 again. That's a big number. And oh, whoa, look at that. Notice it iterated through every number. 2 is not a factor of 49. 3 is not a factor of 49. So notice it's going through every number of the range, and it's not meeting the if test, so it's therefore printing the else test. And so notice this one, number 7, does meet the if test, but nobody else does. So if I were to do the same thing over again, and this time do our 97 number, I'm just going to get a whole bunch of is not a factor of ranges, right? Because all of them are, because it's prime. Now, it would be a nice feature to this, it would be a really nice feature to this program. It would be a nice feature of this program if I could clean this up a little bit. Just getting a long string of things like this is not a factor of, is not a factor of, is not a factor of enough. That would be too much. What I'd rather, I just want to see the factors. And if there are no factors, I would like to let the 6-year-old guy know, hey, this one has no factors because it's prime. So how can we do that? Well, this is going to be interesting. So I need there to be some evaluation at the end. So after this is all over, I need there's some evaluation to happen. So if it makes it through this whole thing, so if it makes it through this if statement, it's got to be prime. So if it makes it through there and prime, it is a prime number, then I want it to go through there. So let's talk about how I can do that. Well, one of my favorite ways to do this is to say something like this. I'll create a variable up here called is prime. So is prime equals to true. And by the way, when you use true false in Python, the T and the F are always capital. I've been through some massive pain because I forgot that problem. All right, so always remember that the capital T in true. So I'm going to set this value. Is prime is going to be true. That's going to be the default value for is prime. And if I get through this if statement, by the way, I'm just going to go ahead and comment out this else statement right now. I'm commenting this out, right? By the way, a pound sign comments out the line of code you don't want to work with right now. So I'm going to say that if this if statement gets processed, right? By the way, but by the way, before I show you this, I'm gonna put a pound sign in front of this. We'll come back to that in a minute. And in fact, I want to let's say, for example, I wanted to have the if statement continue to function until it found one of these is true. If I wanted to find till one of these true, you can actually do this command called break. So what break will do is the if statement will continue to function. By the way, that has to be tabbed in. Well, this if statement, as soon as one of these if statements is true, I will break out of the for. So break will kill the for loop and knock you back and continue on with your code. Let's watch what that happens. In fact, let's go ahead and take this pound sign off our else thing here. There we go. So I'm going to save it now. And I want to show you what that does, just to give you an idea of what happens to the break command. So I'm going to run factoring. I'll say 49 again. And notice 2 is not a factor of 49, 3 is not 4, is not 5, is not 6, 7 is a factor of 49, and that one was true, right? So I'm in this if statement, it is true, and it then breaks, right? And leaves, and it no longer does the else statement, see? So the else statement no longer continues. So that's one way to do it. The problem with doing it this way is I don't see any other factors, right? So if I were to do a much larger number, like 100, so I'm going to go ahead and do 100. Notice it stops right at 2. I don't see any of the other factors because I broke out. So let's go ahead and put a pound sign in front of break. Let's put a pound sign in front of else, pound sign in front of print, and we will remove our is prime is true. So we're going to enter into this now with this concept that whatever number I put in, the variable is prime will be true by default. Okay. Now, if you go through this for loop, right, then what I want to do is I want to say, if you make it through the for loop, then I'm going to say is prime is equal to false. Because if you have a number that makes it through this for loop, and this is true, this statement right here is true, that means it has a factor, and therefore it is not prime. So I'm going to say is prime is false at that point. However, if I get to the very end of this for statement, and I'm not going to indent underneath the for, but if the for statement completes, and if is prime is still true, so if is prime is still true after going through this for loop, then what do I know? Well, colon, I know print that the whole number is prime. So I'll say whole number, comma, and we'll just say is prime, exclam, right? So we'll know that that whole number is prime. Follow me? I'm saying is prime is a variable called is prime is equal to true. I'm running through the for loop. If the for loop matches as true, it will set is prime to false. When I get through this, if I get through this whole thing and prime was never set to false, then I will go ahead and print this concept that the whole number is prime. So let's go ahead and run this whole thing again. Oh, I got to save my changes. Let's watch what happens. So let me do 49 again. 7 is a factor of 49 because 7. Oh, something happened totally different. Notice it did not give me a whole. I removed this else statement, right? So it did not give me a string of things, and it ended more gracefully. So what I could say is, after this, I could say, what could I do? I could say else, right? Else, print, congrats on finding the factors for, I got to put all this in a quote. Congrats on finding the factors for, comma, whole number. Let's see what that does. So I'm going to save my changes. Let's do 49 again. There we go. So now we know that when I got through with this, is prime was false, so therefore it went to the else print. Congrats on finding the factors for the whole number, right? So I now know that I'm at the end. So let's try a number. Let's try a number that has a lot more factors, like 100. And there we go. 2 is a factor of 100 because 2 times 50 is, yeah. So these are all, and then congrats on finding the factors for 100. Right, so now I found all the factors for 100. So this is really cool. I mean, I would love to have had this in 6th grade because this would have saved my life on tests, because I always sat there with a scrap piece of paper trying to figure out all the factors. All right, so now let's go ahead and see what happens when we put in a prime number. So we'll put in the prime number 7. 7 is prime, all right? We'll try a larger number just to make sure it works. Boom, there you go. I bet you some of you are dying right now to put in a really big number. So let's see what happens if I put in 9158744. Let's put in some big number. Oh, it found out that 2 is a factor. All right. It's taken a while. It's crunching. The processor's going crazy. It's taking a little while. It's going through every number from 2 all the way up to that number that I put in. What is that, in the billions? In the million. There are 915 million numbers this processor is churning through right now, trying to find factors, right? So we know we have one factor. That number was not prime, obviously, because it ended with an even number. It's got to be divisible by 2. So let's see I wonder how long this is going to take. Maybe I shouldn't have put in that big a number. Maybe I need a more powerful processor. I need to tell the college I need a bigger, badder laptop so I can show really cool prime number finding on my videos. This is taking too long. I'm about ready to quit this. All right, Control C, by the way, breaks you out of this. I'm waiting patiently. All right, I'm no longer waiting patiently. I'm going to Control C out, right? So let's pick a shorter number. I'll pick a shorter number, and there you go. It's cranking all the factors. It's going through them rather rapidly. Boom, we found all the factors. So we can put a very large number in there, and it would eventually find all of the factors for that particular number. Pretty cool, huh? There you go. Now, we'll wrap up the video here by getting into while loops. So while loops will continue to execute a condition, and we'll continue to evaluate that until it becomes false. So as long as the condition remains true, the while loop will continue on and on and on and on. Now, we can sit here and figure out a way to do this exact same thing that we just did with a while loop. But I got another idea. One thing I like to do with a while loop is I like to increment a count at the end of my code. So let's say, for example, I wanted to give the user the ability to process 5 numbers for factoring. So let's say if I wanted to do that, I'm going to use a variable, and I always set the variable current, I'll call it like current count, and I'll set that to 0. So this variable called current count is 0. Now what I can do then is I can say while, so I'm going to do this while loop, and let me put some space here. So I've got this while loop. So while, and then while works the same way as for. I have to give it a statement that it's going to evaluate. So let's say while the current count is, we'll say while the current count is less than 5, right? So while the current count is less than 5, then I want to process everything underneath here. And by the way, this has to have a semicolon at the end. And I have to tab all these in, by the way, because everything in here has to run in that while loop. So I'm going to go ahead and just put this all in there. There we go. Make sure I get all my indentations right. There we go. So while this current count is less than 5, go ahead and process this, right? But what I have to do here at the end is I have to say that the current count, right, which is right now set to 0. So current count is set to 0 right now. What I have to do is take the current count and make that equal to the current count plus 1. So that the number that's on current count will get added to every time it makes it through the for loop. So every time it makes it through this for loop, it's going to add current count to 1 and then go back up to the while loop, right? So I'm going to keep going back up to this while loop. The while loop's going to continue running, and every time I get through the for loop, I'm going to be adding 1, adding 1, adding 1, adding 1, until finally the number gets greater than 5, or it gets 5 or greater, and then that will end, right? So let's go ahead and try that. Let's see if I made any mistakes. I think I got it right. Let's try that, and we'll run this. What? Oh, so I would like to look for 7. All right, 7 is prime. It's asking me again. So it's going to ask me a second time. So my loop is working. My while loop is correct. 11. 11 is prime. Let me see if I can guess another prime number. Woohoo! 17. Guessing another prime number. Woohoo! Number, 27. Yay, I did it. So I made, I know, let's count how many it did. 1, 2, 3, 4, 5. So it made it through all 5 and then it exited out, right? In fact, you could even say, you could probably give yourself a message here, print, thanks for factoring 5 numbers. All right, let's see if that works. So I'll run, there we go, 7, 11, 100, 50, 23, there, 20. Thanks for factoring 5 numbers. All right, so then when the while loop got done, it went ahead and printed the command at the end. So while loops and for loops can be used together interchangeably. They can use to solve different problems, but they definitely help you figure out lots of interesting things. So hopefully you had a lot of fun learning about for and while loops. You now probably have enough to make this age check thing we did a lot easier now. You could probably figure out some better ways to do it. Some of you, by the way, did turn in this with a bunch of while loops. So thank you very much. That must have been fun for you to figure out. And now the assignment I'm giving out for you is going to be a magic 8-ball assignment. I'm going to give you some code that works with a magic 8-ball. And then what I want you to do is figure out how you can convert that code into looping in order to make it much more elegant than it is now. So that's going to be your assignment this week. All right, thank you very much. Bye.